when we talk about that electrons and then the different so you know that sometimes the Nobel prizes are given to finding out this and that. If you have gone through, especially the Nobel Prize awarded for chemistry, especially chemistry, physics. So those are very fine results they got, because they go for a so the very small, very small, the micron level particle they analyze, right? In that level, most of the time the errors are very minimum. But in our time, so in our as an undergrad or the most of the researchers basically get some results near to the true value. You need not to worry about that, right? But if you can get some idea to give some kind of a the information about your sample, then it may be okay. But in the case of then initial point of view, you have to take many good results. And also if you are going to measure the toxicity level and kind of thing, then you need to get a very good results, right? So accordingly now, basically when we talk about these analyses, the separation techniques are very important. So why the separation techniques are important? Because I mentioned you in the most of the time that they are in when we do analysis, there are, so for example, let's say now we are going to analyze the protein content of the cake, right? We want to analyze the protein content of the cake. You know what are the ingredients of the cake. So what are the ingredients in cake? Let me know. What are the other ingredients in the cake? Ingredients in the cake? You have no idea. Oh, can't you hear me? Okay. You know how to prepare the cake, right? So I'll check that with the voice also. Okay, now you know how to prepare the cake. Then there are the egg also there, flour also there, then butter, sugar, basically, and the leavening agents are there basically in the basic cake. Let's say it's a normal cake. Let's see, right, butter cake. Then, so if we are going to analyze for the protein content in the cake, you know that the protein can come from the flour, as the gluten protein, wheat flour, as well as from the egg, right? But we know that the protein is not coming from the butter. Sometimes butter also getting from the fat from butter fat. Sometimes the protein can be there in the butter fat, right? Butter fat, sugar. Therefore, you have some idea about then how these things are coming, right? Then when we so if we want to therefore if we want to analyze if we want to get the protein content of the cake, if we mention about or if we tell about we can find out the egg protein. What is the protein available in the egg? If we are going to tell that the egg protein content is equal to the protein content in the cake, it's wrong, right? So therefore, what we have to do is normally in the protein content in the cake is coming from many ingredients. Therefore, that means it is actually represent the whole protein content in the cake. Therefore, not only from the egg, only from the flour, not only from the butter fat, not only from the basically those three, not only from each only from one item. So all item get together, then we can analyze the protein content, right? But when we analyze the protein content, but if the moisture is sometimes the moisture is there, it won't be a problem. But basically, if the oil is there, the butter fat is there, or the butter, the lipids are there, then it is difficult to analyze the protein, because lipid is not supporting to digest all the thing, or the liquidize all the thing in the HNO3. Therefore, basically we want to remove the fat, and then we can get a we can analyze the, we can digest it, because protein normally go for a three steps are there: digestion, and then the first is digestion step, second step is removing or getting the ammonia from the out of that the digested sample, and then we trap it and we do the titration. Therefore, 3 steps are there. Then at the first point, if there are lipids a lot available, then it won't be a good thing to analyze the protein. It is interfering, the lipid is interfering in protein analysis. We call the word interfering. Lipid interfere into protein analysis. Therefore, basically, if it is a lipid, lipid based product, then we have to remove the lipid, and then get the lipid or fat free sample, and then we have to analyze the fat free sample for a protein content. Only that way we can tell that protein content of the sample, whatever the cake or the butter or bun or whatever the thing. So we have to do that like that. So then now you can understand that therefore there should be a separation technique. So how we can separate from the butter, the cake sample, how we can separate the fat from the cake sample. Initially we have to do the separation, and then only we can go for a next thing. Yes, Naveen, still I haven't started the recording. So I will do it now, right? So because right. Separation techniques. Separation techniques are really very important in such case, because in some other molecules or other compounds or other the complexes, if those things are involving in whatever the analysis we are going to do, then we have to carry out the separation first and remove that the interference, and then only we can carry out the experiment. So that is why the separation techniques are important. So let's see what are the separation techniques we can use in this situation. Right. So especially we call this the analytical separation. Right. We call it the analytical separation. So the then therefore we have to think about the analytical separation. How we can separate the interference, or how we can remove the interference from the analysis is very important. If any measurement technique used for chemical analysis are specific for a single chemical species. Normally when we do the chemical analysis, now food analysis, there are many analyses we are carried out, and up to now even you have done fat analysis, moisture analysis, and I think the next week you will do the protein analysis, right? And so therefore you know that the different chemical analyses are going on, but we are targeting only one single chemical species. At the moisture determination, you have targeted only the moisture H2O molecule. When you are going to analyze the fat analysis, you are targeting only the fat. In that point, in that analysis, you are not targeting any protein or any carbohydrates or any moistures, right? Therefore, normally in the chemical analysis, we are targeting specific, a single chemical species. Therefore, if there are some other chemical species mean the compounds or the molecules, chemical species are disturbing us for our analysis. At the first step, we want to remove them from the, or we have to mask them. We call it to mask them. Sometimes we can remove them from the system. If not so, we can mask them. It is there, but not, we are not allowed them to interfere to our experiment. Therefore, we have to do the masking, or we have to do the we have not them to, we do not allow them to involve our analysis. But most analyze means what we are going to analyze, right? What is the compound or the molecular species or molecular, we call the name analyze. The most analyzed are dealing with foreign substances, but especially the case is that analyte, what we are going to analysis. So these compounds, most of the time they are dealing with the other foreign substances. They are not, they are as a separate unique molecule. It is always bind with other compounds. Therefore, first we have to remove them, or mask them, or separate them. Then only we have to do the chemical analysis for our target chemical species. The substances that affect an analytical signal is called as interference or an interferent, right? Now you got to know that the other technical term, interference or an interferent. The substance that affect an analytical signal is called as interference or an interferent. Now, for example, here we call the analytical signal, right? Now, here we are not going to talk about the weighing or the titration or likewise, but we are going to talk about the more advanced techniques, because under the practical component of yours, we are talking parallelly in the normal analytical techniques, right? But all the lectures are focused for a very advanced technique. Advanced mean actually those are, we can't say it's much advanced, but you have to understand what are the basics. Then only once you come to the undergrad level and your fourth year, or sometimes before that even, you have to engage in some analysis in that case. So you have to use this kind of the instrument, right? For example, spectrophotometer, already you know. Colorimeter, you have you know how to operate the colorimeter. Spectrophotometer. Then there is a gas chromatography meter. The techniques are there. And when we talk the chromatography techniques, there are a lot of chromatography techniques we have to, in the separate machines are there for analysis the sample. So therefore, then there's ICP-MS. So the more advanced, when we talk about those things, it's a mass spectroscopy. We are the NMR. I think you have heard those things, the NMR analysis. So likewise, there are very advanced techniques are there. So when we do these things, normally we also use those machines for our analysis, right? In that case, so that interference substances affect an analytical signal, and those compounds or the substances we call interference or an interferent, right? I think up to now, are you all right? Have you got the point what I'm going to talk about today's lecture? Any question? If I ask you the question, so what is the interference? So can you explain? Define interference or an interferent. Okay, define now. In the chat box, you can write it. Define interference or an interferent. Define it. What is the interference or an interferent? Give the answer. If you understood the things up to now, then you will be able to answer. What is an interference or interference? How you can explain it? Veerasurya, how you can explain this interference and interferent? SW Veerasurya.
Hello, madam. I think the interference means the substance that interrupting uh, to what we need to analyze. I mean, when we need to analyze protein, lipid, it is a lipid-based product. The lipid is the interferent.
Right. So the basically, so the answer is correct. But rather than come to the example, but you have not mentioned the chemical species. Tell again, Veerasurya. Interference is
Interference is a chemical species that interrupt when doing
interrupt the analysis.
analysis.
Interrupt the analysis. That's all. So therefore, the interrupting or the disturbing, that word should be there, chemical species should be there, and then the interference and interference. So the very few words you can use and substance whose presence any substance whose presence interferes with an analytical procedure. It's not the analytical procedure actually. It's we can't say the analytical procedure is a different step. Many steps are there in the analytical procedure, but it's at the analysis or when we are going to take the measurement, at that point that chemical species disturbing us, and it make a different complexes. So whatever the way, it's disturbing us to take a true results, the true accurate results. The disturbance caused for an analyte or signal by a foreign substances. Interferent, the substance that cause the to the analyte signal. The interference or an interferent, both are the interference or the or an interferent, both are same. I think you got the point. So in any case, right, in the most of the case, these things are there. For example, let's say now you know how to do the moisture analysis. In the moisture analysis, even that if the volatiles are there, if there are some esters or the volatiles are there, or sometimes the oil-based volatiles, sometimes the flavor-based volatiles. Likewise, if the volatiles are there, definitely it will be affecting to the moisture determination. But a little, maybe 0.001, however that is the some kind of interference, right? But you need not to worry. Then sometimes so when we talk about the interference, interference make it but in the using the correct analytical procedure, we can separate them or mask them, or we can remove them, or we can inert them, not to involve in our analysis. Sometimes we have to remove them, sometimes they have to inert them or make a inert chemical species. I think you got the point now. What is interference or an interferent? thank you for all the guys who give the answer. Let's see, let's do new. Navanithan, Vijay Singha, and then Rajivani, Kosala, and many mentioned the answers. Then let's see methods for eliminating interference in chemical analysis. Now there are many methods we can use eliminating interferences in a chemical analysis. So one is the masking. Other one is a mechanical phase separation. So under distillation, extraction, ion exchange kind, many things are there. Then the chromatography, we can do the chromatography and also we can do the electrophoresis. Now let's see about these different methods one by one. When we talk about the masking, right? Right. Masking. In masking, a reagent is added to the solution of a sample to immobilize or chemically bind the interferent as a complex. In masking, a reagent is added to the solution of the sample to immobilize or chemically bind the interferent as a complex. Now, once it's immobilized or if it is mobile only, එක යන්න පුළුවන් නම් හැම point එකටම විතරයි එයා disturb කරන්නේ. If the chemical species can't move in your solution or within your sample, so then it won't be a problem for us. Therefore, we have to, because you know that, let's say now in your class, even if you are working somewhere very හිට මේට ඇවිල්ලා කරදර කරනවා අරක මොකක් හරි කියනවා so මේක මොකක් හරි කියනවා නැත්නම් තව ටෙක්නිකල් තව මොකක් හරි කියනවා අරක අහනවා මේක අහනවා it's so much disturbing for you to concentrate for your work. So සමහර ගෙවල් චූටි බබාලා ඉන්නකොට එහෙම එනවනේ ඇවිල්ලා අක්කගේ බබා හරි අයියාගේ බබා හරි ඉන්නවා මොනවද කරන්නේ නැන්දේ මාමේ කියලා අහගෙන ඇවිල්ලා එක එක කරදර කරන්නේ අර කැදයි යනවා ෆෝන් එක අරන් යනවා මොනවා හරි ඒ වගේ it's disturbing, right? At that time what you do ගොඩක් ලාට ගන්න කාමරේ දොර වහගන්න එක, right? එහෙම නැත්තම් කියනවා අක්කට හරි sorry කාට හරි කියනවා වගේ please අනේ මෙයා පොඩ්ඩක් හරි කරන් තියෙනවා මට දැන් ලෙක්චර් එකක් තියෙනවා මට එයා disturb කරනවා. So likewise, so we take some kind of action to remove that interference from our work. හරි අපිට වැඩ කරන එකෙන් පොඩ්ඩක් එයාව අයින් කරගන්නවා, right? So සමහරවිට අම්මා ඇවිල්ලා හරදර කරනවා ඉන්න අම්මා මම ලෙක්චර් එකක් පොඩ්ඩක් ඉන්න දැන් කතා කරන්න බෑ. So likewise ටිකක් ඉතින් පෙන්නන්න හදනවානේ අපිත් lectures ගන්නවා කියලා online, right? So ඒ වගේ මේ පොඩි දන්නවනේ දැන් මාස්කින් කරන වැඩ තියෙනවා. සමහරකට so if you are the group එකක් කතා කරගෙන ඉන්නකොට කවුරු හරි එනවා disturb ඉන්නේ ආයව මාස්ක් කරන්න මොකක් හරි කරලා කතාවක් කියලා එහෙම තියෙන්නේ ඔය චූටි කාලේ ඔය වගේ වැඩ කරලා ඇති ඕන් තරම් ඉස්කෝලේ යන කාලේ A level and university, so likewise then you know what is how to do the masking. In masking, a reagent is added to the solution of a sample to immobilize or chemically bind the interferent as a complex. So that reagent what we are going to use it is also not reactive substances, but it is that interferent the complex what we are going to make a complex that is also not a reactive one. So non-reactive complex we are going to make. If not so, if we are going to make a reactive complex, then it will giving a more disturbing. Therefore, we are going to prepare a interferent non-reactive one, no longer contribute to the signal from the analyte. So whatever the signal we are going to take, sometimes we are going to take as a signal because absorbance is a signal, and chromatography techniques we are going to take the signal. So the noises are signal, sensors are giving us the signal. So therefore, we want to disturb in those things, interference, and because it is not going to signal from the line. For example, when we do the lectures here, right, online lectures, sometimes I can hear and all other guys can hear in the who participate for the lecture. කවුරුහරි ගෙදර කෑ ගහනවා පිටිපස්සේ ඉඳන්. ඒක ඇහෙනවනේ. එතකොට ඒක ඩිස්ටර්බ් ඉන්නේ. එතකොට පොඩ්ඩක් ඉතින් එක්ක මම හුඟක් ලාර කරන්නේ චෙක් කරලා බලලා මියුට් කරලා දානවා. එයාව මාස්ක් කරලා දානවා. So have you remember the last time, the one person disturbed us a lot? Have you remember that? ඔගලා ක්ලාස් එකේ නේද ඒක උනේ? දිගටම ඩිස්ටර්බ් කරගෙන හිටියා. පස්සේ අපිට හොයාගන්න බැරි වෙලා අන්තිමට එයාව සම්පූර්ණ ක්ලාස් එකෙන් අපි අපේ වෙලා we have removed them නේ. දිගටම ඩිස්ටර්බ් කරා. Have you remember that? So we mask them because that the host can send throw the person away, right? The host can block that person. So therefore the host can mute the phone, host can unmute your phone, host can open your video and open කරන්න බෑ මං හිතන්නේ, but the host has all authority to how to manage the class, right? So likewise here also no longer contribute to the signal from the light. Example, use of fluoride ion to prevent iron 3 from interfering in the ionometric determination of copper. So here, if we are going to do the ionometric determination of copper 2, then the iron 3 also going to interfering, because iron and copper both are they are the chemicals, minerals, and therefore in that case, so we are going to remove the iron from the system using the fluoride, right? So kind of different interference we can remove by the system. So that we call it a masking. So in some situation, have you remember you are using the EDTA in some titration, and so the kind of different situations we are used, right, not to interfere the things. And sometimes you have seen that when we do the especially we have faced that sometime when we do the lectures in the LT2 hall, right? That time in the other side there is some drilling is going on, and some constructions are going on. Actually very disturbing. That time we send a message sometimes that the downstairs, that the auditorium, the lectures in the auditorium or the meeting in the auditorium also disturbing the LT2. So those are the interfering. In such situation, what we do is we stop the interference. So give me a few seconds. One lecture is interfering. So any question up to that point? Do you have any question? Precipitation and filtration? Sorry, masking. I think now you understood what we call masking. Then let's do the other thing is the precipitation and filtration. So the filtration, that LiO and interference is removed from a solution selectivity as an insoluble species. So here actually the answer is given here. But what we do here, the LiO and interferent is removed from a solution selectivity as an insoluble species. So this one they use dimethyl glycine to separate nickel from most other heavy metal cation, but it's in the more chemistry. But let's discuss. I mentioned about the protein analysis. So the protein analysis in the lipid is disturbing. In that situation, what we do is first we dissolve all the lipids in the non-polar solution, and maybe hexane or sometimes maybe methanol. Especially we use the hexane in that case because hexane is very selective to dissolve fats. Hexane is very selective, very good non-polar solution or solvent, and it's very selective for a fat. Therefore, first we wash our sample using the hexane, and then, or sometimes we hexane, and then we remove the fat from the sample, and then we go for a protein analysis. So therefore, in that case, we do not the precipitation, we do not do the filtration, but we dissolve in the solvent and then remove the fat from the analysis or disturbance from the analysis. Sometimes we do the precipitation or sometimes we do the filtration. So the precipitation, to do the precipitation especially, we have to use some other substances. But in the case of filtration, now let's see in that way. Now you want to analyze let's say the carotene content in the carrot sample, right? Carotene content in the carrot samples. You know that the carotene is there in the pumpkin or these almost all the yellow color fruits and vegetables are having the carotene. Not only the yellow color, green color things also having carotene, because you know that when the leaves are going to ripen or the old age, or before it's fallen down, all the chlorophylls are going or the masking, and the carotene are coming prominent. That is why you can see most of the leaves are becoming a yellow color. It's showing their carotene, not chlorophyll, right? So likewise, here also that the in the case of carotene, we want to analyze from the carrot sample there. Now let's see. Now first we have to dry the carrot sample, and because in the first we want to remove the moisture, because we can't analyze the moisture. If the moisture is there, we can't get the carotene. Therefore, we have to remove the H2O or the moisture or the water. For that one, what we do is we dry the sample and remove the moisture. So after that we get the dry sample, and so even that the dry sample, you can't analyze the carotene, right? Because carotene is there in the bind with the other cells. Therefore, we want to take the carotene out. So what we have to do is, because the fibers are there, carbohydrates are there, protein some amounts are there, some minerals are there, a lot of other vitamins are there, different vitamins, different enzymes are, we can basically out from the remove from the system by drying. So likewise, we have to inactivate the thing, or we have to remove that other item and get the carotene out. Then only we can analyze the carotene content. Then what we do is we can so normally that the carotene can dissolve in the methanol, or sometimes the hexane is the most suitable solvent. So therefore, what we do is that dry sample we have to extract with the hexane. Then the lipid soluble carotene can be come to the hexane, and then we can analyze that hexane, carotene with hexane, we can analyze for the carotene. I think you can understand what I am telling. Then what we do is, once we put the hexane and we shake it for a long, maybe let's say the 1 hour, 2 hour, or likewise, so that we can shake it, and then we allow all carotene to come with hexane, come to the, or they come, go to the hexane. Then what are the other things available there? All fibers, all protein, all the carbohydrates, everything is there, polysaccharides are there. Then what we do is we do the filtration. We filter the sample. After we filter the sample only, so the we can get the hexane with carotene. Then we analyze the hexane for carotene and get the carotene content. So what is the steps we have taken here? We dry the sample to remove the moisture, and then we use the hexane, and then we do the filtration. And after that, we do the carotene analysis. So therefore, all the aldehyde and interferon is removed from a solution selectivity as an insoluble species. If it is a chemical analysis is going on only chemical, like a solvent, then what we need to do is we have to separate the soluble thing. And if not so, likewise filtration we can do. Precipitation and filtration both we can do. If not so, the filtration we do to always to separate some precipitated molecule, right? So these are the technique I am talking about, the masking and the precipitation and mechanical phase separation, precipitation and filtration. Those are the technique, basic technique that I take the example from food science and especially food analysis. Then the next one is separating species by distillation. So they're widely used to separate volatile analytes from non-volatile interferences. Because, so for example, let's see now you know that we want to analyze the cinnamon oil, right? We want to analyze what is the active compound in the cinnamon. කුණුදු වල තියෙන active compound එක මොකක්ද? Have you remember anyone? Cinnamon. What is the active compound? Cinnamaldehyde. Good. Right. So we want to analyze the amount of cinnamaldehyde in let's say in cinnamon sample, right? So can we analyze let's say now cinnamaldehyde content in the bark, cinnamon bark and cinnamon leaves. So what we can do by taking the bark or by taking the leaves, can we analyze the cinnamaldehyde? No, we can't. Therefore, first we have to separate the cinnamaldehyde. It's a volatile compound. Therefore, we have to get the oil out from from bark or cinnamon bark or cinnamon leaves by distillation method. And after that, we can analyze by using the chromatography techniques what is the amount of cinnamaldehyde available in the sample, right? So therefore, sometimes we have to do the separating species by distillation, like especially the volatile analytes. Distillation we do. In other case, we do distillation. Let me know you have done the distillation now. You know about that. What is the other distillation method we have used? Separating species. Give me an example. You have done it for the practical. තාම කරේ නෑ practical, but video එක දැක්කනේ නිකන් කළා වගේ තමයි, right? What's the answer? How about yesterday's practical? Yes, I think you know that. Let's see what is your answer. Yes, you have done it in the Soxhlet method. You have done for a goldfish method. You have done to analyze fat content, right? In that method you have used that distillation method. So what they do, that sample is having fat, but they can't analyze the fat by using the distillation. Sorry, using the direct, we can't analyze it. Therefore, what you have to do is you have to take the fat to the petroleum ether or hexane or sometimes acetone. Likewise, so the whatever the non-polar solvent we have to use and take the fat out, then only we measure the fat content. There even you have used the distillation method, especially the goldfish method and the successor method. So now you can understand what is the separating species and the by distillation, right? For the especially now you have done the principles of food science, you have done the fat, you have learned about the fat. Fat basically is there the high what is it? Saturated fatty acids are there, unsaturated fatty acids are there, then polyunsaturated fatty acids are there. Likewise, the fatty acid are there. Then if you want to analyze the fatty acid composition of fish sample, then what you have to do? You have to dry the sample, and then first you have to remove the moisture, and then get the dry fish, and after that dried fish, and after that you have to do the distillation and you have to separate the fat, and then only that fat you can use for analysis of the fatty acid composition. I think now, so now you can understand how you are going to use what you have learned in the previous semesters, right? So therefore the separating species by now here the species we call, let's say the fatty acid composition. So fatty acids. So you want to analyze the palmitic acid, you want to analyze the oleic acid amount. That is a chemical species. So therefore, some steps you have to follow, and then finally you have to do the distillation and then get the fat out, because palmitic acid or oleic acid is there in the fat layer of the sample, or fat or in the fat in the sample. Therefore, separation of nitrogen analyzed from many other species by converting the nitrogen to ammonia, which is then distilled from basic solution. So this one, have you done nitrogen analysis? I think not yet. In the next week, you are going to do the protein analysis. Have you done? The practical reading material have you received? Protein analysis? I think no. So therefore, in the next week, I think you are going to use you are going to do the protein analysis. In there, you can understand that the distillation step is going on, right? I mentioned you the one is the digestion, second one is the distillation, third one is the titration. So the three steps are there. The second one is distillation. After digestion, we convert the nitrogen to the ammonia, and then ammonia we distill and trap it, and then collect into the volumetric flask, right, or the conical flask. And after that, so we titrate it with because ammonia now is getting a acidic condition. After that we base condition, then we titrate it and do some calculation to measure get the value for the protein content. So separating solids by extraction, that one. Solids distribute themselves between two immiscible liquid differs enormously, and these differences have been used to separate chemical species. Now, in some time that we are going to use all chemical species are there in the one solution. Sometimes it is there in the aqueous solution, sometimes in the organic solvent. So in that case, we have to separate it and take it out to do the next analysis. So very useful technique for very rapid and clean separation of both organic and inorganic substances. Because if you are going to analyze organic substances or the inorganic substances, in such situation, the separating solids by extraction is really important. So let's see what is it. Here, the solvent extraction principle we have to learn in this situation, because there are two phases are there. Distribution coefficient is the new term I think you are going to understand or learn. Solute S distributes in two phases within in limits, maybe temperature and pressure, because when the temperature change, the separate distribution coefficient is depend on the temperature as well as the pressure, because temperature and pressure make some changes to the solvents. So because if the temperature increase, then the mobility is increased, therefore the distribution coefficient increase. Then again the mobility increase, and therefore in a low temperature, even if the pressure decrease, then the mobility increase and the distribution coefficient increase. So therefore the distribution coefficient is depend on the temperature and pressure. It says solute S distributes in two phases within limits, and the ratio of the concentration of the solute in the two phase will be a constant, right? So that means transfer of solute from phase 1 to phase 2, we can say, now if there is you can see the picture, if there is an organic solvent and then the aqueous solvent, and also the other one, fluorous, right? Now let's see now the organic solvent and aqueous solvents are there. Organic, and let's see the chloroform, and there is water, right? Then chloroform and water is not going to dissolve at all. When you put the chloroform and water together, so you can see it's a separate in the two phases, right? Then if there are some solutes or the analyte, if it is preferred to go to the organic layer, then if it is there in the aqueous layer, even it try to go to the organic layer. If there are some analytes in the organic layer, if it is more preferred to come to the aqueous layer, then it move to the aqueous layer. So therefore, after some time, it come to the equilibrium, right? After some time, it come to the equilibrium, and when it come to the equilibrium, that the phase separation you can see very clearly. Then if we are going to, if we know that this analyte is now in the organic layer, then we get the organic layer and we continue our analysis. If we know that these compounds in the aqueous layer, then we take the aqueous layer and do the next analysis. So likewise, so we can this solvent extraction principle is very important. So basically here you have to know that the distribution coefficient, it can be changed depending on the temperature and pressure, and also the ratio of concentration of the solute in the two phases will be constant. It is constant, but constant, therefore in the given temperature and pressure, that whatever this solute or the analyte, it go to the preferred phase and stay there. Therefore, all the time it try to go to the preferred phase, and therefore what we have to do is we take the preferred phase of that analyte what we are going to analyze, and then we can continue our analysis. Now here see this picture. S is a solute in phase 1, and after the equilibrium, after we keep some time, the S is now in the phase 2, right? Therefore, if at the initial position, a lot of solute is in the phase 1, but time being, it much prefers to stay in the phase 2. Therefore, it goes to phase 2 and stay there, and after some time, it is according to the distribution coefficient, as much as solute is go to the phase 2. So normally what we write the distribution coefficient is K, and it says that the amount of solute in the phase 2 divided by the amount of solute in the phase 1, right? So let's try to understand more about this with this equation. If the solid species A allowed to distribute itself between water and an organic phase, the resulting equilibrium means once they come to the equilibrium level, the species A in aqueous phase, and then species A in the organic phase it's not same, but whatever the phase it like to go, it is there in the more amount. That means now in the equilibrium level, A solute A in the aqueous level and the A solute in organic level come to the equilibrium level. The ratio of activities for A in two phases constant in any given temperature, and it says the A solute available in the organic solvent divided by the A solute available in the aqueous solvent. Right? So this is a key. Again, let's go to this point. This equation has deleted. What happened? Okay, you write down this AI is the remaining concentration of A in the aqueous solution after extracting B aqueous milliliter of the solution having an original concentration of A0. Original concentration in we call A0 with I portion of the organic solvent with the volume B volume in organic. So can you take a small note about this one, these lines? You can take a snapshot, or sometime if not so you have to take a note. AI, that means the solute A Okay, it says that, now think that there is a solute called A, right? Solute called A is there in an aqueous solution. Solute called A is there in the aqueous solution. So, but solute A is much preferred to go to the organic solvent. ඒක වැඩිපුර කැමති organic solvent එකකට තමයි වැඩිපුර ඇදිලා යන්නේ. නමුත් දැන්ට එයා ඉන්නේ aqueous solution එකේ, එයා කැමති organic එකට. Therefore, you can use the organic solvent. Let's say the volume of the organic solvent is 10 milliliters. If there is a 10 milliliters, so the 10 milliliters water පුළුවන් දාන්න, you can use 10 milliliter. One time you can use 10 milliliter, and now organic solvent and aqueous solution is separate. Now you are taking the organic solvent, organic එක අයින් කරගන්නවා. ආයෙත් දානවා 10 ml. So you can put again the 10 ml, and again you shake it and keep it to settle. Then again because A like to go to the organic solvent, therefore it again transfers to the organic solvent. Right? Then ඒකත් අයින් කරගන්නවා. You have to put again the organic solvent V volume. Let's say again 10 ml. So you have to shake it. After that, So you keep it settled. After that, again you remove the organic solvent. So once you keep the eye portion, again eye portion කියන්නේ that need sometimes 10 ml sorry 30 ml one time or sometimes 15 ml two times. දැන් 30ක් කියන එක අපිට පුළුවන් 10 3කට ගන්න පුළුවන් 15 2කට ගන්න පුළුවන් 30 1කට ගන්න පුළුවන් right. එතකොට මේ eye portion එකක් තමයි මේක අපි පාවිච්චි කරන්නේ right. So the එහෙම පාවිච්චි කරාට පස්සේ so if it is so just a moment. So after removing like that, still even after you use the eye portion means the 30 or 15 into 2 times or 10 into 3 times. So after using that even, still that the A solute is available in the remaining in the aqueous solution. So the here said the because at the beginning we use the V volume of the aqueous 30 milliliters of water තිබ්බා කියලා ඒක තමයි now A කියන එක තිබ්බේ. දැන් අපි 10 ඒවා තුන් පාරක් දාන්න පුළුවන් 30ක් වෙන්නේ. එමෙන්න අපි 30 ඒවා එකක් දාන්න පුළුවන්. එහෙම නැත්නම් 15 ඒවා දෙකක් දාන්න පුළුවන්. එහෙම ගත්තට පස්සෙත් කොච්චරක් තව AI මේ තියෙනවද equation solution එකේ කියන එක තමයි calculate කරලා බලන්නේ මේ equation එකේ. Unfortunately equation එක මෙතන නැහැ. මැකිලා. So the මටත් මතක නැහැ. අපි ඊගා step එකට යමු. Here you can find out the equation. මට ඔයගලන්ට equation එක හොයලා දෙන්න වෙනවා. So the Yasara, are you there? Yasara? So can you note down this example please? May example note down. So we are going to calculate some questions, right? We are going to get some answers. Therefore, please note down this. හරියට ලියා ගන්න. ඔයාලා ලියන්න නැතුව හරියට මේක note down කරගන්න. So take your calculator to nearby you and get ready for a අපි ගණන් ටිකක් දැන් හදනවා මේකේ. So we are going to do some sums. Have you noted down the equation? Sorry, have you noted down the question? Yes, I will give the break now, and 5 minutes. Therefore, take a break, and then we will continue the lecture. Right? into K is a coefficient, and plus V aqueous into I time multiplied by A0, right? So the AI is the remaining concentration of A in the aqueous solution after extracting V aqueous milliliter of the solution having an original concentration of AO with ith portion of the organic solvent with the volume BO, right? So note down this equation, this very important equation. Out of that you can understand how this separation is going to happen, as well as, so though we have done different separation, different extraction times, or the times of extraction, but still there are something remain in the previous solution, right? So let's go to the next slide. Example, I have asked you to note down this example. The distribution constant for iodine between an organic solvent and H2O is 85. So the distribution constant is K is 85. So now write down K equal 85. Find the concentration of I2. I2 means the iodine remaining in the aqueous layer after extraction of 50 milliliter of 1 into 10 to the following quantities. Now what is the VAQ? What is it? It's a 50. VAQ equal 50. K equal 85. Then what is the iodine concentration? Iodine concentration, it says, original concentration of iodine is AO. So what is the original concentration? AO equal 1 into 10 to the power minus 3 molar is the original concentration. Now you have three points, right? Three known items you have now. Then with the now they are going to use the organic solvent, the quantity. The first time they use only the 50 milliliter, right? 50 milliliter at once. එක පාරක් 50 විතරක් දාලා ඒගොල්ලෝ concentration එක හරි ගස්සනවා, right? So let me know what would be the answer. So if 50 milliliter is V org is 50. Now you have no V aqueous is 50, V org again 50, K is 85, V aqueous is again 50, AO is 1 into 10 to the power minus 3, right? I equal 1 because only one time they have used. Let me know what is the answer. Let me know what is the answer. A answer is 1.16 into 10 to the power minus 5, right? So someone has mentioned this is the answer, 1.16 into 10 to the power minus 5. Okay, let's see if that the answer is correct. Yes, answer is correct. 1.16 into 10 to the power minus 5. Answer is correct. Then remaining iodine concentration. Remaining iodine concentration in the sample is 1.16 into 10 to the power minus 5 when you use 50 ml at once, right? Then go to the second one, the B. B says, right, see everyone got the answer. Then the second time what they do is they use 25 ml 2 times. So the total one is the 50. They have used the 25 into 2 times. Now apply the same values to the previous equation and see, and let me know what would be the answer. K equal 85, A0, if not so, original concentration 1 into 10 to the power minus 3. Aqueous layer volume is 50 ml. It is not changed. There is aqueous layer aqueous volume is 50 ml. But this time they have used the organic solvent 25 milliliters 2 times. Then what would be the answer? Right. So let's see what is the answer. 5.28 into 10 to the power minus 7. Yes, you are correct. You got the second as an answer for a B is 5.28 into 10 to the power minus 7. Now calculate again. Go to the 5 times 10 ml. 5 times 10 ml. 5 times 10 ml when you are going to get the 5 times now. Then in the equation here the I is 5. V of 10, K 85, V aqueous 50, A0 1 into 10 to the power minus 3, V aqueous 50. Then I is 5. Then what would be the answer? 5.29 into 10 to the power minus 10. Let's see whether you have got the correct answer. Yes, let's see. Yes, answer is 5.29 into 10 to the power minus 10. Right, very good. මේකට දුන්නොත් මේක තමයි මට තියෙන ප්‍රශ්නේ. ඔච්චරත් කියලා දුන්නත් අඩුම ගානේ කීප දෙනාට වැඩි වරද්දන ඕක හරියට හදාගන්නේ නැහැ. පටලව ගන්නවා. So if anyone has question regarding ඔයගලන්ට තේරුණාද? Have you got this answer? The answers have you got? If you have still not get the answer, please let me know. Then mama I කියලා දෙන්නම්. මේක හරියට ඔලුවට දාගන්න. So what you have to do is apply these values to the equation. But what I want to tell you that you can see that here the answer is showing you that what is the amount remaining in the aqueous solution. Now I2 50 ml one time පාවිච්චි කරපුවාම 1.16 into 10 to the power minus 5 remaining in the aqueous solution. When we are using the I2 into 2, let's see, 25 into 2 times පාවිච්චි කරපුවාම, so you can see that the remaining volume is 5.28 into 10 to the power minus 7. So which one is the A is the greater one or the B is the greater one? Which one is the greater one? A or B? Which one is the greater value? First one or second one? Which is the greater value? A, B, C, out of that, A is the greater value. Out of B and C, which one is the greater value? Out of B and C, which one is the greater value? In between B and C, what would be the greater value? කොයි එකද වැඩි? A, B the වැඩි, C the වැඩි? B වැඩි. Right, good. Very good. Right, now you can see, now A is having the greater value, A තමයි වැඩිම, B next, and C is the next. Right, third one is C. Now here I want to tell you that when you are analyzing the 50 ml one time, aqueous solution, the remaining component of the remaining solute in the aqueous solution is much higher. When we are using the 50 ml not at once, 2 times, 25 දෙපාරක් දාපුවාම, so the 2 times දාපුවම ඔයාලට ඊට වැඩි අඩු ප්‍රමාණයක් remain වෙන්නේ. So the larger portion will be come to the organic solvent. When we are using the 5 times 10 ml දාපුවාම, more lesser amount is remaining there in the aqueous solution, and you can get the more amount to the organic solvent. So that is why this is the base of the separation technique. If you want to extract something from the original compound, rather than you are going to use, it's not only one time. If you're going to 2 times, then you can extract more. If you are going to 3 times, you can extract more. If you're going to 4 times, you can extract more. So likewise, therefore the separation time, when you increase the separation time, you can get more amount to the your sample, right? Your solution. I think you got the point. So very good. Everyone is very alert to the lecture. I'm happy about that. So therefore මේක තේරෙන්නේ නැත්නම් හෙට කාගෙන් හරි අහගෙන හරි මේක තේරෙන්න මට උත්තරය ආවේ නැහැ ඇයි කියලා. So you can send your picture කොහොමද හැදුවේ කියලා, then you can get it, right? Right. Now let's go to the next one, because we talk about we are talking about this one. Masking we have discussed, mechanical phase separation we have discussed, precipitation, filtration finish, distillation finish, extraction finish. Now we are going to talk about the ion exchange. So ion exchange, right? So the separating ions by ion exchange, it is a process by which ions held on porous, essentially insoluble solid are exchanged for ion in a solution that is brought in contact. Held on porous, essentially insoluble solids are exchanged for ion in a solution that is brought in a contact with the solid. Clay and zeolite are the example. Synthetic ion exchange resins are commonly used for water softening, water deionization, solution purification, and ion separation. What we are doing here, so separating ions by ion exchange is one other method. What is doing here? So you know, very basically, chuti kale dakka neda me. So the same thing, same technique you have used to separate, get the clear water from the muddy water. I think at the grade primary level or sometime in the very early level of the junior high school, you have done it. Have you done it, anyone? ලොකු ගල් කැට පුරවනවා, the larger stone, tutti stone, the next medium size, again that sometimes the charcoal you have put අඟුරු කැට දානවා. If not so, you are using the sand. එහෙම දාලා have you prepared a bottle? Anyone has done it? Then say yes or no. What we do there? Have you done it in the school level? That is the same thing, because we can use the clay or zeolite like different item, different material to exchange the iron, right? Here, so you can separate the muddy particles out of that. Sometimes it's a filtration, but if you are putting the charcoal like that, definitely that the ion exchange is going on. Because it is you are getting many because ions are there, those ions are absorbed to the clay, those ions are absorbed with zeolite. Therefore the rest of the thing is going on, and purification, water deionization, solution purification, so water softening. So this method is using separating ions by ion exchange. So when we come to the analytical technique or in the analytical chemical analysis, we use different ions in this, but the principle is the same, but we use a different type of ion for this purpose, right? Are you clear up to that point? Yes or no, Naveen? Can you hear me?
Yes, madam.
Right, good.
Yes, madam.
Thank you. Now let's go to the sample preparation, solvent and solid phase extraction. So this is something different. Now go to the first, what we have learned up to now. Now the mechanical phase separation, precipitation, filtration, you know, distillation, you know, extraction, you know, and exchange, you know. Right? Then the chromatography and electrophoresis are the rest of the thing what we can use for chromatography, electrophoresis. And now don't worry about that. It's a very simple technique, chromatography, and right. sample preparation, solvent and solid phase extraction. Right? Here the chromatographic technique is analyzing complex samples whereby multiple analytes are separated on a column and detected as they emerge from the column. Impurities may affect for the proper detection. Clean up is needed prior to the application to the column. Right? Now here what we do is, so the chromatographic technique is a very sensitive technique. If we can go to the sensitivity section, you have seen that the sensitivities in the chromatographic technique is very high, very good, and therefore, therefore we finally go for a different chromatographic techniques. But the thing is, the analyzing complex samples whereby multiple analytes are separated on a column. Now, chromatographic technique, basically what we use is the column. Now, when you are using the muddy sample to get the muddy water sample to the purified sample or the water filters so what we do is we use a column. Have you seen the column? The pet bottle layers දාපුවම we call it a column. ඒ column එකට උඩට දැම්ම අපි අපිරිසිදු වතුර දාන්නේ යටින් අපිට පිරිසිදු වතුර එනවා. So that is a normal column technique. So the analyzing complex sample whereby multiple analytes are separated. Then අපි column making, now we are going to talk about the chromatographic technique columns. Those are very fine one, and also it's a very selective. So because though they are selective, if we are going to if our sample is having lot of analytes, ගොඩාක් analyte තියෙනවා නම් ඒක disturb කරනවා අපිට whatever sample we are going to analyze. For example, take the carotenoids, right? We are going to analyze carotenoids in the carrot. When we talk about the carotenoids, there are different type of carotenoids are available. For example, beta carotenoid, leucine, and xanthine, and the beta xanthine. So likewise, there are different carotenoids are available. But those all carotenoids are coming as a coming as a together. So we can't say that මේ පැත්තේ තියෙන්නේ උඩ තියෙන්නේ බීටා කාරොනේට් යට තියෙන්නේ සැන්ට්‍රෝෆිල් එහෙම නැත්නම් අපිට කියන්න මැද තියෙන ලෙව්ටින් එහෙම කියන්න බෑ. Everything is together. So therefore we want to analyze this complex sample. Because there are multiple analytes are separated on a column. Then of course if you are under column chromatography, then all samples are separated together and detected as they emerge from the column. එකින් එක එළියට එනකොට column එක එළියෙන් මොකද ඉස්සෙල්ලා ඉන්න එකක් ඊගාවට එන්නේ තව එකක් ඊගාවට එන්නේ තව එකක්. So likewise one by one analyte coming out, and all the things are detected at as they emerge from the column. But impurities may affect for the proper detection. Then අපිට ඕනේ ඔක්කොම බීටා කාරොනේට්ස් වර්ග ටික ඇනලයිස් කරගන්න. නමුත් ඒකේ තව වර්ග තියෙනවනේ. වෙන මොනවා හරි තව polyphenols වර්ග තියෙන්න පුළුවන්. ඒක අපිට ප්‍රශ්නයක් නෑ, අපි ඒ ටික අයින් කරන්න ඕනේ, right? So the impurities may affect for the proper detection. Clean up is needed prior to the application to the column, right? For example, let's see. Now I mentioned you we are going to use the carrot sample, right? In the similar way, we are going to analyze the pumpkin sample. In the pumpkin sample, we use not only the middle part, we take the skin also. Now skin is having the chlorophyll, because skin is a green color. Rather than chlorophyll තියෙනවා green color na chlorophyll කියලා. දැන් chlorophyll එකත් එක මුළු pumpkin කෑල්ලම කපලා ගන්නවා. So we blend it, and we are not getting only the yellow color, but green color chlorophyll is also there. But definitely chlorophyll disturbing to our analysis. Therefore, what we want to do is, because chlorophyll again result in the hex, so it will be disturbing us. Therefore, we want to remove the chlorophyll. In such case, we want to clean up the sample. Only we want to get the මේ රෙකෝඩින් යන්නේ නැද්ද? Thank you. මෙතන පොයින්ට් එකේ ඉඳන්ම ගියේ නෑ නේද? රෙකෝඩින් එක නමින් මේකටත් ගියේ නෑ නේද? But
Yes, madam.
ගාන නම් ප්‍රශ්නයක් නැති වෙයි නේද everyone? තේරෙයිද ඒගොල්ලන්ට? Now in this example, you can see when we use the 50 ml, that means the much amount at once, the remaining iodine is there, large number. When you use the 2 times 50 ml, 25 ml 2 times, then the two extraction, then you can see that there are lower amount of ions, iodine ion remaining in the aqueous system. 5.28 into 10 to the power minus 7, it's a lower amount compared to the 1.16 into 10 to the power minus 5. When you extract it the 5 times, 10 into 5 times, you can see that there is a more lesser amount remaining in the aqueous solution. Most of the iodine are come to the organic solvent. So likewise here what the concept is, if you want to extract something from the original sample by using the different solvent, so you have to do it not on the one time, you have to try it in the carry out in the 2 or 3 times, at least 3 times. Then many of the analytes in the original sample you can get separate to the your for further analysis steps. So then let's go to the separating ions by ion exchange. So they are the very simply, I think you have done it in your childhood, that the separating from the getting the pure water from the muddy water. There you take the PET bottle and cut it, and so the top, and after that you fill some the cotton wool, after that the charcoal, after that sand, after that the borolu or the bit bigger size porous stones, and then the more bigger size, more bigger. So however you fill it, right? After that, once you introduce the muddy water, but later on you can get the very pure water, because most of the muds and the different the impurities and some particles, everything remaining there in the column, but finally you will get the very nice pure water, right? There is also the column system you basically use. It says that the very pure one is coming and the one of the impurities will be remaining. In the similarly, when you are going to analyze by using the very different equipment, especially the chromatography or the sometimes you are the spectrophotometry or the NMR, likewise when you are going to use the different equipment in the higher rank one, in such situation, what you have to do is you have to use the columns. Columns are the kind of, there may be the ion exchange column resins, so the different columns we can use. Especially these columns, you practically at your the normal life. Water softening, water purification columns are there, water deionization columns are there. If you go to the laboratory, you can see the water deionization column. Solution purification columns are there. Ions in you can see web search, so you can identify these ion exchange different resins, right? So why we are going to use it? We want to remove the impurities and we want to take our sample out to go for a further analysis. Now, so that is why chromatographic techniques we can use in a two situation. Sometimes analyzing complex samples whereby multiple analytes are separated. There are multiple analytes are there. I can go back analyze, A, B, C, D, E, F කියලා පහක් තියෙනවා. දැන් එතකොට so you want to analyze the amount of B, amount of A, amount of B, amount of C, amount of D, amount of E, amount of F. So all 6 you want to analyze what is the amount is there. In such situation, we can use the chromatography technique, because in the chromatography technique is again we use the column, right? You use the column. And therefore in that column, so once you introduce your sample at the from the top, so then it come one by one. After coming one, then the second one will be coming, then the third one, then the fourth one. Sometimes it is not coming as a B, C, D, E, F in that way. It may be B come first, C come next, D come next, then A. Likewise, whatever the way, when it go through the column, so the column separate each and every component and let it to go out from the column. So it is depend on the different situation. We are going to talk it in the later. So therefore, that is the image, the analyzing complex sample whereby multiple analytes are separated on a column and detected as they emerge from the column. Detected as they emerge from the column. So එකින් එක එළියට එනකොට තමයි ඒක detect කරන්නේ. ඔක්කොම එකට එන්නේ නැහැ. So that is the very important thing is chromatographic techniques, and therefore for that one we have to prepare our sample. Impurities may affect for the earlier. We can't say that the impurities are coming later or impurities coming up first or impurities are coming middle. We can't say. We know that they how our analytes are coming. What is the which one is come first, which one is the second. We can have some idea, because we have to run the standard first and make it if not, so we have to go for a mass analysis, mass spectroscopy analysis. So so we have to know that the very so which one is come first. But if the impurities are there, definitely it will disturb our sample analysis. Therefore, cleanup is needed prior to the application to the column, right? So prior to the application of a sample to the column, we have to do the cleanup. So the cleanup means, for example, so let's say now we are going to extract the beta carotene from pumpkin sample, or beta carotene from, let's say, moringa sample, moringa leaves. So because beta carotene is there in the moringa leaves a lot. Oh, but the thing is, moringa leaves looks like green, not the yellow. So green means there are many chlorophylls are there. So with the chlorophyll, we can't analyze the beta carotene types in the moringa sample. Moringa leaf sample. Therefore, we have to separate remove the chlorophyll first, and only we have to get them, then take only the catalyst, and after that, if we run for a chromatography, then we can get the different, we can analyze what is the amount of beta carotene there, what is the amount of lutein is there, what is the amount of beta xanthine is there, so beta xanthine is there likewise, so we can analyze, right? Therefore, the sample preparation is very important, and before we use the chromatographic technique. Now here we are going to use, because why I am using the word chromatographic technique. Chromatographic technique is the most suitable technique. We can analyze each and every analyte. So it is very clearly give us, so beta carotenoid is this amount, then lutein is this amount, and beta xanthine is this amount. Likewise, we can analyze. In the other case, let's see now the T sample. The T sample is having different catechins, different type of epicatechin and epicatechin galactate. Likewise, different catechin components are there. Then if we are going to analyze the T sample for catechin, we can't use that the only the whatever the tea infusion, right? Tea infusion, because catechin. So if we are going to analyze the catechin, so we have to separate it. The particle inject we can't inject the particle to the column. We want to get the extract. So therefore, so likewise, we want to separate it and get the whatever the catechin, the liquid catechin, not the liquid catechin, to the solvent, and then we inject the solvent. After that, when we run the chromatography, so we can separate and get the real amount is there in different catechin type, right? කොහොමත් ඔයගලන්ට මේව involve වෙනවා in the fourth year එකට යනකොට, especially in the people who are working in the food science department, they will work on these things. Many of students will get the chance. මේක අමාරු නෑ, හරිම, right? Right, it's 7:30 now. So the isolating analytes from the complex sample, right? So the two methods are very useful: solvent extraction and solid phase extraction. Solvent extraction and solid phase extraction. So what is a solid phase extraction is hydrophobic functional groups are bonded to solid particle surface and act as the extracting phase. They reduce the need for large volume of organic solvent. Now here what we do is solid phase extraction, hydrophobic functional group. Hydrophobic කියන්නේ වතුරට කැමති නැති, water dislike. Functional groups are bonded to solid particle surface and act as the extracting phase. They reduce the need for large volume of organic solvent, because now if there are some as earlier, so if we want to get the organic that hydrophobic functional group, if we want to rise, then if now everything is there in the aqueous solution, we have to use the different or the many organic solvents. විසිපස්වරක් පහහරි ඒ වගේ ගොඩාක් organic solvent පාවිච්චි කරන්න වෙනවා. So but it is a really wasting of the solvent. So what we can do with the organic solvent once we extract the sample, so that is why here the solid phase separation we can use. Hydrophobic function groups are bonded to the solid particle surface. ඒකේ කරන්නේ අපි solid particle එකක් තියෙනවා. ඒකට අර hydrophobic groups bind කරනවා. We bind it, and then the aqueous things are going on. ඒක එළියට යනවා. ඊට පස්සේ after that, now all hydrophobic groups are there in the bonded to solid particle. No? After that, you add the organic solvent and take it out. Now, when organic solvents are going to the solid particle surface, so they all happy to release from the, or the it's gave up, or the detached from the particle surface and go with the organic solvents. So that one we call solid phase extraction. Other one is a solvent extraction. Solid distribute themselves between two immiscible liquids. These differences have been used to separate chemical species. That is solvent extraction is the previous one what I have discussed with you. Very useful technique for very rapid and clean separation of both organic and inorganic substances. So this is also the solvent extraction also very okay. It's a good, but it is depend on the which separation technique we are going to use is depend on the sample what we are going to analyze. Right. So let's finish this one. Solvent extraction is a very useful technique for very rapid and clean separation of both organic and inorganic substances. Then solid phase extraction, many difficulties are avoided by this method. When solvent are shaken, they tend to form emulsion. So in that case, because in sometimes you can see when you are using the organic and aqueous solvent together, when you are shaking, they form emulsion. In such situation, we can't see that they are very clearly separated two solvents, right? Aqueous and organic solvent, we can't see very clear separation. In that case, we can avoid that case by using solid phase extraction. And also, it is need relatively large solvent. Waste disposal problem is there, right? So therefore the difficulty is there when we are using when they need the large amount of solvent, or the waste disposal. Therefore, the waste disposal problem is there. In such situation, as a good solution is using the solid phase extraction. This one is widely used prior chromatography as cleanup step, right? So I think it's clear for you how to use that in solid phase extraction. In this technique, hydrophobic organic functional groups are chemically bonded to solid surface, for example, powdered silica, and commonly use carbon 18 chain on silica particle size 40 micrometer. Very small silica particles are there, 40 micrometer. And also the carbon 18 chain is bonded, or if not so, it's bonded on this silica particle, silica ball. සිලිකා බෝල් එක නැත්නම් සිලිකා පාටිකල් එක උඩ කාබන් 18 එක පේස්ට් කරලා තියෙන්නේ. එහෙම නැත්නම් ඒක දාලා තියෙන්නේ. Therefore the separation is happening by using the carbon 18 chain එක. ඉඳ තමයි වෙන්නේ. Because ඒක තමයි absorb කරන් තියාගෙන ඉඳලා අවශ්‍ය වෙලාවට release කරන්නේ. Not the silica. These groups will interact with hydrophobic organic groups by van der Waals forces, hydrogen bonding, and electrostatic attraction. So how these hydrophobic organic functional groups are bonded with the carbon 18 by using the van der Waals forces, hydrogen bonding, and electrostatic attraction. Again, hydrophobic organic functional groups are bonded to the carbon 18 chain, which is placed on the silica particle. Silica වල නෙමෙයි වෙන්නේ carbon 18 අර bond ගාලා තියෙන නැත්නම් surface එකේ apply කරලා තියෙන එකෙන් තමයි මේක සිද්ධ වෙන්නේ, right? And extract them from an X-ray sample in contact with the solid surface. Solid surface එක හරහා යනකොට when it go through the solid phase, that the hydrophobic functional groups attached to the carbon 18 chain. Carbon 18 that surface silica එකේ surface එකේ carbon 18 එකට attach වෙනවා, because carbon 18 also hydrophobic and non-component. Then they can be eluted with the solvents such as methanol, right? So after that, first you have to run the aqueous, then we are going to run the methanol. For further analysis, concentrated sample may be needed to activate the silica bed before applying hydrophobic sample passing through methanol over the silica bed. So what we do here, now first silica bed is there in the column. First we add the methanol to activate the surface, carbon 18 surface. After that, we add the aqueous sample, and whatever the hydrophobic functional group in the aqueous sample attached to the carbon 18 surface, carbon 18 on the surface of the silica. And after that, once we run all the aqueous sample, then we run methanol. When the methanol is going on, methanol is very happy to attach with the hydrophobic functional group. Then methanol is taking those functional groups to the out of the column. So this is the separation solid phase extraction technique, right? Are there any questions? It's a time for questions. If you can't understand, please ask now with asking questions. Any questions? Have you understood everything? හොඳටම තේරුණා? දැන් මේක දිහා බැලුවාම ආපහු තේරෙයි කියලා හිතන්න එපා. අහනවා නම් දැන් question එකම අහන්න. So Kosala, are you all right? Have you understood? Tashmila, how about you? Have you understood or not understood? Do I need to explain it again? Not today, other day? Because next day we are going to talk about the chromatographic technique directly. Or sometimes spectrophotometry, let's discuss. So, do you have any question? So seems that the share. Any questions? Yeah. As you don't have any question, and so 9:30, sorry, 7:37. So I'm going to stop the lecture now, and let's meet on next Monday. So I'll inform you the time I'm going to take the lectures. So I think it's if I'm really happy to have take the lectures in the early morning rather than the evening. So let's see. Right. Okay. Good night to you all.
Good night, madam.